think what I'm thinking. Okay, tweet is sent. So, Sue Carney, thank you so much for joining me. I have heard such great things about you, so I have no doubt that you're going to live up to what's been said.
No pressure then, okay.
No pressure at all. So why don't we get started and tell us a little bit about yourself. How did you start in the world of forensics?
Gosh, many moons ago, I was really fascinated by DNA. I can remember being at school, God, that was a long time ago, being at school and learning about, and that was in the 80s, God, learning about something called PCR. I can remember reading about it in New Scientist or something, I think, and thinking, this is brilliant, not knowing that in years to come, I would be using PCR and in the work I do. And so I was determined that I wanted to work with DNA, really, and that was my only sort of idea, because I was really fascinated by it. So I did the usual things, you know, did my A-level biology amongst others, did a degree in genetics and microbiology at Sheffield University, which was thoroughly enjoyable. Did a master's degree, which was a master's by research, which was quite nice. It wasn't a taught master's. You got to actually do hands-on stuff in the lab, which was great. And I won't bore you with my project title. It was to do with yeasts. So I was working with the yeast Candida albicans, which is the yeast that causes nasty thrush infections, amongst other things, and dealing with that. I did that, and then when I finished my master's, I was wondering, should I do a PhD? What should I do? And of course, money was a real driver. So I ended up getting some part-time jobs and temporary jobs to pay for things, because I had a mortgage by that point. God, you know, so you needed to pay the bills. So I ended up working for British Gas, good old British Gas, in doing financial things. Really nice job, really great people to work with, but it wasn't really what I wanted to be doing. And when they asked me to do some accountancy qualifications, I just thought, right, this is the time to get out, because I don't want to be an accountant. No disrespect to accountants, it just didn't float my boat, you know. So I applied for a job that had come up. It was a trainee forensic scientist job at the Forensic Science Service. And that whole process of applying took a really long time, actually. I don't know if that was just how they did things back then, but everything seemed to take quite a long time in the civil service in general. And so I got the job eventually and started in 2001, did a good 18 months worth of training in-house, and then finally was let loose on real casework. They call it being signed off. So I was signed off as a kind of almost a probationary forensic scientist, let loose on real cases. And they started off as really simple ones, things like blood swabs, nothing complicated. They don't let you loose on murder on your first day. And then worked there until it closed. Our lab closed in 2011. Thank you, David Cameron. He closed down the Forensic Science Service, and many of the other labs went. It was all gone by 2012. And so I then started my own business, kind of by accident, really. And here we are now.
I mean, I understand the longevity of, you know, it's not just in the civil service. When I had to go through 7 interviews to get my job as a CSI, including like psychometric testing. I had to do an MO test, and then we got put in a house. Like, you know, you just said 18 months there. We were in a house for, I think it was 7 months learning before we were allowed on the scene. I mean, obviously the FSS, you know, it has a huge legacy. It's still strong, and it's something great to like practice on. So what would you think that was the main thing that you've got out of, what was your favorite thing to get from all your experience back then?
That's a really difficult question. I guess all of the experience is really valuable. The thing I love the most about working at the FSS, which is probably not the question you asked, but the thing I like working most was just the people that I work with, because there's some fantastic people. And when I left, I was in the sexual offences team, and we dealt primarily with rape and sexual assault cases. But the people I worked with were brilliant. They kind of, at our lab, which was the lab in Chorley in Lancashire, the sexual offences team were kind of locked away in an upstairs room because we were talking filth all day, basically, about all kinds of things, you know, that, not by choice, but because it was all casework related. So they kind of hid us away from everybody else. And by the end, it was a women only team. By the end, not for any particular reason, I think, just because it worked out that way. There are a lot of women in forensic science anyway, and so some bright spark christened this office the ovary, because it was all women, and men would kind of enter with trepidation, because usually when they entered the office for whatever reason, they'd get harassed about, can we just ask you a question, you know, can we ask, usually an embarrassing question. And so yeah, that was the best thing, the people that I worked with, and, you know, those relationships. And I'm still in touch with quite a few of those people now, you know, and some of them are really, really good friends. So
I guess also, like, working together, you have the kind of the same sense of humour, which people don't always understand when you leave the industry.
No, well, you know, a lot of people who work in those kind of grim jobs talk, don't they, about having a kind of gallows humour. And it's totally true. It gets you through. You know, you would say things and joke about things that were really in poor taste, I guess, to everybody else. But it's a coping mechanism. You know, when you're spending the best part of your day looking at in detail at all the really horrible things that people do to each other, it can have a huge effect. You know, so that is one coping mechanism. And I won't tell you some of the awful jokes, but, you know, we understood that it meant no disrespect to anybody involved in any of the cases we worked on. It was just our way of getting through, and that was hugely important, I think.
Absolutely. I mean, especially people probably wouldn't understand so much now, because obviously we have help for like mental health and to get through things. But I know, you know, even after your experience, like I didn't get that much mental health, occupational health in my role. I can't imagine that you got offered it either, but some of the police did, but it wasn't quite as good as it is now.
They did have counselling at the FSS, and I know that the existing forensic service providers now who have kind of stepped into that role that the FSS had, I know that they have very good provision for their members of staff. There's an interesting article, actually, that you can probably look up on LinkedIn, written by a friend and colleague of mine, Jess Adby, who works for Key Forensic Services, and she's written a real from the heart piece about the mental health issues that we can suffer as forensic scientists. It's really worth a read. That's Jess Adby from Key Forensics. You can probably look it up. It's probably on their website as well, actually.
I think it's important, definitely, to make sure that, you know, that people do think when they go into a job that they see all the read all stuff in the papers, and they see all of the shows, and they don't really think about the bigger issues that you can face on a day-to-day basis. Definitely, we'll have a look into that one.
Sure.
But obviously, like in your work after you left the FSS, you then did quite a bit of travelling. You've done quite a lot of going out and about. Have you got a case that sticks with you?
Oh God, there are loads. I've been really privileged, actually, and really lucky to have had such great travel opportunities since starting my own business. Gosh, which trip? I mean, I've been all over the place. I've been over into the Middle East and to Africa. I was lucky enough to go to Uganda. I've been to, where else have I been to? I was in Mumbai recently. That was quite an upsetting case. But the one that really sticks in my mind is a case that I dealt with in Georgia, not Georgia in the US, Georgia the country. So I went on 2 trips to the capital of Georgia, Tbilisi, which is a beautiful place. But the case was a quite horrific stabbing of a schoolboy, essentially. It was kind of a school fight that got out of hand, and my role was to examine some of the fabric damage to the clothing of the boy who'd been stabbed. And the aim of that was to have a look at whether any particular weapons could have caused that damage or could be excluded from causing that damage. So that it was interesting from that point of view, because people don't understand, I guess, so I should clarify this, that fabric damage traditionally within forensic science in the UK is normally dealt with and is part of the training of forensic biologists, which sounds a bit odd because, It's not really forensic biology at all, but it fits with the types of cases that we do. So often many of us are trained in that. But the reason it was such a memorable case was because of the people that I met over, and it always comes down to the people, doesn't it? The people that I met over in Georgia, we were doing a kind of a joint re-examination of the exhibits, myself and a colleague, Jason Payne-James, who's a forensic doctor. He was looking at the post-mortem results, that kind of thing. And we were doing this joint examination with Georgian experts. And so we had to have a lab to use over in Georgia. And we were using a university lab run by a fantastic professor whose name I can kind of remember, but I won't attempt to pronounce because it's quite long and complicated. But he was brilliant. The whole trip was very surreal because we were followed around a lot by the press, and we were on the local news just because we were there, which was very weird and disconcerting. But this professor was a fantastic guy. He let us into his lab, showed us around his lab, and he was extremely proud of all the facilities, which was great. But he showed us his firing range. And neither Jason or I are experts in kind of firearms and ballistics, but he said, you know, do you want to go? Do you want to go with this Luger? And I said, thank you, but no, because I was worried that this kind of homemade looking firing range, what was at the other end? If I fire this weapon, where might the bullet end up? You know, it was probably perfectly safe, but I just thought I'd rather not do that. And then later on, he said, I bet I'm the only gun-toting professor that you've met. I said, yes, you are. And it turned out, he said, well, never mind. I don't mind that you didn't use the Luger. I prefer this one. And took a pistol out of his pocket, you know, half an hour later in the middle of a meeting. It was very, very bizarre. There's certainly a different way of doing things. But it was great fun. We did some really valuable, it wasn't all fun and games, you know, we did some really important work on the exhibits as well, you know, in re-examining this damage and doing test damage, where basically what you have to do is take the alleged weapon and do some test cuts on the same item, so you get to actually do some stabbing. And usually the best way to do it, if you haven't got anything else, is to use a kind of a joint of meat to put the item over, so it almost simulates stabbing into a person. So that's a bit of a weird thing to do, but quite satisfying, you know. So we've got some quite interesting results from that case, but that was the most memorable one. It was a really, really, of all the trips I've been on, perhaps the most surreal. Yeah.
It sounds like there's definitely more than just getting the tool marks out of that. It's a whole different
exactly. Yeah.
community. Obviously with the role that you do now, because you are looking into cases that get given to you, aren't you? So you don't work for the police force. So can you just like give me a little run through about what your role is now working for Ethos Forensics? Well,
largely my work is now instructed by the defence. So if you think about it, when anybody is accused of a crime, they have the right to have a defence and to re-examine any of the evidence against them. And so as a defence instructed expert, my role is usually to review the work that has already been instructed by the police and has been done usually by one of the three big forensic providers in the UK. So I'll go and review that work. Often that's a paper-based exercise. It might be just, you know, reading the prosecution instructed experts' statements, having a look at the DNA results that they've interpreted. It may be as simple as saying whether I agree or disagree with their interpretation. Sometimes it's more complicated than that. It might be that defence counsel have specific questions that they would like an answer to because they feel that perhaps something hasn't been explained well enough. So often you find yourself explaining things that perhaps already have been explained, but sometimes it's just beneficial for the reader or the user of that evidence to have it explained in a different way. So there's a lot of re-explaining things. Sometimes there's a re-examination of exhibits. So if it's for me, a blood pattern analysis case, photos often aren't good enough. You really need to go and actually have a look at those exhibits. So I will go and visit whichever the prosecution instructed laboratory was. I'll go and visit them and go and have a look at the exhibits. And then I will write a statement summarising all of that. Sometimes it's a complete reinterpretation, sometimes it's just answering specific questions. But it's worth pointing out, I think this is an important point for people who don't know, that it doesn't really matter as a forensic scientist whether you're instructed by the prosecution or the defence. Overall, the kind of needs are the same in that we're all impartial experts. You know, we can only sort of describe or talk about what the evidence is saying, you know. So it's useful from a defence point of view, I think, if they have a particular version of events that hasn't been suggested before, and they want to know, does that version of events kind of fit with the evidence that exists already or not? You know, that's straightforward. But there's often a misconception that people who are instructed by the defence or kind of work for the defence are working for the dark side. That's what it's often described as, you know, God, you've gone over to the dark side. And actually, I kind of push back against this. Now, I remember I used to think that when I worked for the FSS, but you are not there to sort of as a defence instructed expert, you're not there necessarily to sort of muddy the waters or make things more confusing in the hope that the evidence against the defendant will somehow be diluted or will go away. That is not what our role is. But I think people often think that that's what our role is. And so I always like to say, no, you know, we are experts in exactly the same way as the prosecution instructed experts are, and we're all impartial. And more often than not, you find when you review a case like that you agree with much of what the prosecution has said already. It's very rare, actually, that there's a huge fundamental disagreement between prosecution and defence experts. That doesn't happen that often.
I guess also because, like, you are trying to get to the end goal, aren't you? The fact is that a blood spatter analysis may be a small differentiation on opinion, but it's not going to be a resoundingly huge difference.
No, usually not. Not, I would say, unless something really wrong has happened, you know, something's really gone wrong. The only reason I think there would ever be a real change of opinion or a difference of opinion would be if actually some new information came to light. You know, so sometimes what happens is the defence will offer a possible explanation for some evidence or some new piece of information that the prosecution instructed expert didn't have at the point when they were making their interpretation. And in those circumstances, what usually happens is, if that changes things, the prosecution expert may well say themselves, actually, now I've been given this new information, that changes my opinion. And all of us as experts should be willing to review our opinion and change our opinion if the circumstances change, because forensic science is never done in isolation. It's contextual. So it depends on usually two versions of events representing prosecution and defence, and then other surrounding information that we call the conditioning information, things that are going to affect what evidence might be transferred or what might be recovered after something's happened. So you always have to be ready to adjust your opinion. It's most disconcerting when you have to do that opinion adjustment whilst you're in the witness box, you know, because that's when you've been told this new information, and that can be quite tricky. So you need a bit of training to kind of get you ready for that. I think that's important.
And obviously, you know, obviously we've spoken previously about watching TV shows, but I think a lot of people don't realise that, you know, you have to use your own kind of sensitivities to when you go into a court case. It's not a case of that they'll just chuck anybody on the stand. You know, you're an expert for a reason, and there's a big differentiation between someone who's collecting evidence and someone like you giving your opinion.
What I find when I'm teaching my students, what I often find is that they're not necessarily aware of the different roles in forensic science. So there are people who do the recovery of evidence at crime scenes. You know all about that, Alex. CSIs used to be called senior crime officers. Some police forces call them different things, but usually it's CSIs these days, isn't it? So the CSIs gather all the evidence and recover things from the crime scene, package them appropriately. That's fundamental, because if that is done wrong in the first instance, then whatever you do to those exhibits afterwards doesn't really matter. You know, that's got to be right first. Then what usually happens is the exhibits, the evidence, whatever it is, recovered items, are submitted to a laboratory somewhere. And in the UK, there are 3 main ones who do work for the police. And within those organisations, there are people who are reporting officers. They are classed as expert witnesses. So that was my role at the FSS, and I still consider myself essentially to be a reporting officer. So we're the people who kind of decide what the strategy will be in the case. Which items will we examine? What tests will we do? What will we look for? We have to think up front, what might that mean? That's pretty crucial. We do all of that up front. And these days, that decision making happens in conjunction with the police because they have a budget and they're paying for the work. So there's some decision making up front, usually done by the reporting officer or the RO. And then the exhibits will go to an analyst or an examiner, depending on the type of work, and they'll do the lab work. So the first misconception then, from my students' point of view, is that they don't know about these different roles. So they might want to do all the lab work themselves. Well, perhaps they should be going into the realms of examiners and analysts if that's what they want to do. But then they also want to go to court and be expert witnesses, and you kind of can't do both. Not usually. There are some organisations where reporting officers do a little bit of the lab work or do their own lab work as well, and that's great. But if you're working for a really big organisation, you wouldn't have time. You know, you might have 30 or 40 odd cases on your list at any one time as a reporting officer. It would never be feasible for you to do all the lab work in those. You'd be there for years. And so that's usually, with a few exceptions, how it works, and people generally don't realise that. I think another important misconception is that people who've watched CSI or NCIS or all those, you know, and they're great programmes, but people who've watched them think that a forensic scientist is an expert in all areas of forensic science, and that's just simply not true for the most part. We're quite niche, we're very specialised in the areas that are our areas of expertise. So mine is forensic biology, DNA, body fluids, that kind of thing. So I wouldn't touch, you know, footwear evidence, for example, because it's not I know about it, but I would never be able to give an expert opinion on it because I'm not trained to, and it's not my area, you see. So people don't understand that either. They think they can do all of these things, and you have to kind of choose what is your specialist area.
Obviously, especially now as well. I mean, we didn't mention that you were a teacher, but you are in Lancashire. And yeah. I do think that, you know, when I was a student, there was only, I think, 3 institutes in the UK that actually covered forensics and criminology. And now pretty much every uni and institution does it. And I think you're right there. People sometimes are confused about what it actually means, and don't necessarily they have a career path either, because they don't understand that some parts are, you know, you need to focus and you need to be an expert. I mean, you must get a little bit frustrated.
Well, I think that when we're talking about careers, I think the most important thing, and this is what I'll say to students or prospective students, you know, when they come on open days and things like that to my institution, I'll say, pick a subject that you enjoy. That's the winner, you know, that's the most important thing. Because if you don't enjoy your subject, what makes you think you're going to want to spend the rest of your life, you know, in work doing that, whatever subject it is? So pick what you enjoy, and then doors will open later. And I think there's a danger, isn't there, with more vocational degrees like forensic science, that people think they're kind of channeled into one career path. And actually, there are loads of different you know, roles and different career options that you can use a forensic science degree for. And that might not even be forensic science, but if you've got a really good degree because you were interested in the subject, then, you know, you're going to do well in what you're interested in, and then worry about the rest later. I think that would be my advice.
I do feel that, especially I've noticed a lot of people are into crime, and they're into murder, and they're into assault, and that's why they think that they should do a course, and ultimately, you know, that's not really, they're not going to be passionate enough to continue 3 years.
Well, maybe they would, maybe they wouldn't. I think that the biggest drawback is, I guess, people having an idea of what they think forensic science is like. And of course, TV programs and dramas make it look really glamorous and really exciting. And yes, there are some brilliant parts of it. You know, there are some really rewarding aspects, but also you have to understand that much of what we do is really boring. You know, it's really monotonous. I mean, if you've spent 8 hours of your life looking at a smelly training shoe under a microscope, you know, and that's not what I do now, I'm really glad to say, and I have every admiration for the people who still do that to benefit my work and others. But, you know, if you're doing that for 8 hours, they're 8 hours you're never going to get back, you know, but it's so vital that you've spent the time on that one exhibit, because if you miss something, that could be really, really crucial for the case. But it's an understanding that it's not all going to crime scenes and, you know, investigating murderers. Sometimes it's, you know, 8 hours of comparing a bunch of numbers to another bunch of numbers on a graph, you know, and that's my life a lot of the time. I spend most of it sort of, you know, sat in a corner staring at my laptop, either writing or reading something, and it's not as glamorous as you think. But if you enjoy kind of the science of it, and if that's what you want to do, then yes, I guess you're doing the right thing. But maybe people don't kind of get a real feel for what it's like until they do sort of go on a university course or you know, and then they get a real taste for it. So there's something to be said for perhaps making those career decisions later on when you have a bit more knowledge of what actually that career might entail. Or
Absolutely, yeah.
at least trying to find out, you know, listen to things like this and have a chat to people. Because generally, most people who do a job that they're passionate about are willing to talk to sort of the next generation of people who might be doing that job. Yeah.
100%.
So
In finding the whole, you know, the whole ins and outs as well, rather than just one thing that they read in the book.
Yeah. Yeah.
Well, let's talk a little bit about DNA. That's one of it's the title. We put it out there and everywhere. So DNA, I can't even say the right word. DNA profiling is one of your big expertise areas. And DNA has come so far since, you know, we started the DNA database, which Richard Pace, who has said hello, talked about in his he talked about in his last live chat last week. So yeah, talking about DNA profiling, can you give us a little rundown? I know it's a huge area, so how far have we come since the DNA database was started 25 years ago?
God, leaps and bounds. We've come a really long way. So when DNA profiling, DNA fingerprinting, as it was called early on in kind of the late 80s, when it was first pioneered, was kind of completely different to how we do DNA profiling now. It used a different system to kind of target particular areas of DNA. And that was fine. It worked really, really well. It wasn't particularly sensitive back then. So you needed, and this is the biggest change, I think, you needed quite a substantial amount of material to get a good DNA profile. So maybe a decent sized blood stain to hope to get enough DNA to form a DNA profile using the older methods. Since then, during the 90s, we started using a different method which uses something called STRs, and STR stands for short tandem repeats. And basically, an STR is a little region of DNA that has a repeating motif or pattern in it. And we all have within our genome, a genome is a person's total complement of DNA, if you like. In everybody's genome, there are certain regions that contain these STR motifs. So they're quite well characterized. We know about them. And what we're interested in when we're doing DNA profiling is basically looking at each person's STR regions and counting the number of times that repeating pattern repeats. And we can do that by essentially measuring the length of those regions. So without boring you with the bits of exactly how we do that, because it's a bit technical, we measure the length of those particular regions, and then the results of that is displayed in a kind of a graphical representation with peaks on it. And this is quite a sensitive method of DNA profiling. It uses that PCR reaction that I mentioned earlier to produce more copies of the bits of DNA we're interested in. in the early days of STR profiling, we could probably get a good DNA profile from maybe a 10 pence piece size blood stain. If you fast forward to today, the current systems we are using can get the same kind of DNA profile from something that's almost invisible, a blood stain maybe less than 1 millimetre in diameter. We've now gone into doing something where we might test things that don't even have any visible body fluids in there. So let's say we had an exhibit, here's a pen, and we wanted to know who might have handled this. We can potentially swab, maybe can you see there's a ridged bit? That might be a good region to swab for DNA. It might have a buildup of material. So we could swab that, send it off for DNA profiling, and potentially get a DNA profile of someone who last handled that pen. Brilliant, really sensitive. One of my colleagues likes to say, you know, we can detect more and more from less and less. Eventually, we'll be able to detect everything from nothing. And he thinks that's hilarious. Well done, Brian. It is quite funny. He comes and does a guest lecture at my university, and will say that to students, and they all look at him a bit quizzically. But he has got a really, really important point to make, because the problem with increasing the sensitivity again and again and again is that eventually you are detecting levels of DNA so low, sort of background levels, in that there are real limitations to that. Because the problem then is, can I be sure how that DNA got there? Especially when you're dealing with something like this, you know, how did that DNA get there? What if somebody hadn't handled this pen, but happened to have just walked past it, was on a surface, and maybe they coughed or sneezed? That's quite relevant, isn't it, to today's situation? What if a bit of their DNA landed on here and they hadn't handled it? And the problem with these low-level profiles that we can now detect is that we're really limited. We can't say how the DNA got there, or even when it got there. And DNA might persist for quite a while on various items, on surfaces. So you're getting some useful information out of having this really sensitive DNA profiling system, but then you are also getting a bit of ambiguity because you don't know how it got there. And surely, in most cases, that's the question that the court wants us to try and answer. How did that get there? Did it get there by the manner in which is alleged? That might be some kind of assault or burglary or whatever it is. Or could it have got there by some other innocent means? And often, the answer to that question is, we don't know. And the court may not like it when we say we don't know, but often, with a lot of forensic science, that is the real answer. You know, we don't know. There are still limitations to what we can and can't say. So DNA can be hugely powerful, and if you have a really good quality profile, it can be really powerful evidence of whatever it is, depending on the circumstances. But if you're in those low-level realms, sometimes that can be really good evidence, but sometimes it ends up being a little bit more ambiguous, not straightforward, because of those limitations of low-level profiling. And I think people need to be aware of that. And I haven't even started about what happens when there are mixtures of DNA from more than one person, because then things can get really, really complicated.
I guess that's the point of the investigators, isn't it, and the RO officers, to make sure they take into account everything from a scene rather than something small. But on the positive side, the things that we can do now that we couldn't previously, like get DNA from urine. That's a new one, isn't it? And I know you have a story about this.
Yeah, well, this was really interesting, because I was asked to work on I wasn't working on the urine samples. I was asked to review the work that had already been done. And this was a real eye-opener for me, because I didn't know that this was happening. So, you know that when athletes are drug tested, or that anti-doping testing and all of those things, and there's a huge raft of different substances, as I understand it, that they are tested for, and that is totally not my area. But what I hadn't been aware of until quite recently was that what they're doing now, and I don't know if every drug test has this process done, but this was certainly the case with the samples I was asked to look at the results from. What had been done, the samples had been DNA tested just to make sure that the urine was from the person it was supposed to be from. In other words, no, no one had hidden in the toilet and substituted someone else's urine for their drug test sample, basically. So it seems, on the face of it, a quite interesting thing to do, quite a useful thing to do. And of course, one of these tests came back and the DNA profile didn't match the person it was supposed to match. In other words, is this person's urine or not? Or what else might be going on? And of course, the conclusion had been this person was cheating and they'd somehow substituted their urine for somebody else's. So I was asked to look at the results of that. And it was quite an eye-opener. Now, put this in context, urine is not really a good source of DNA. And so kind of pre-2014, probably the systems in place in the UK to do DNA profiling wouldn't have been as sensitive enough to give us a decent profile. We're talking about, low levels of DNA here, perhaps at the limits of detection, a bit like those we were talking about earlier. So what we had in this case was an athlete saying, this is my urine sample, a DNA profiling test from that urine sample, which was very, very low level, not a complete profile. There were bits of information missing, which is not unexpected given the sample, but it didn't appear to match the athlete, and it was a female athlete. I won't give any more details away. But what was interesting, as I delved more into this, there were some second tests. The samples had been tested again by a different organisation, and their lab seemed to have a bit better sensitivity with their DNA profiling, just a slight variation between labs. And their DNA profiling tests for this second set of tests seemed to indicate a male contribution to this female profile. And so then I started to ask some questions about, well, what are the circumstances under which this sample had been taken? And it turned out the athlete whose sample it was had been engaging in sexual activity, we'll call it, with her partner, consensual sexual activity, and then the sample had been taken, I'm not sure exactly how long after that, but certainly after that had happened. So I said, well, perhaps this some of his, perhaps this extra DNA we're seeing is from sperm, perhaps that's what's in there, because you might expect that sort of draining, I won't use the anatomical body parts, but you know what I mean, from that region, urination can sort of accelerate loss of semen from those regions. So maybe I was thinking, is there any sperm in this? So we managed to get hold of the DNA profile of the chap, her husband. So far, so good. It seemed to match. And then finally, the actual lab were instructed to actually look for sperm in the urine sample. So I'd written quite a lengthy report with lots of possible reasons, and that was one of them. I didn't have the samples, so I couldn't do any of testing of my own. I don't have a lab anyway. So finally, after reading my report, they looked in the urine, was there any sperm there? And there was. Brilliant. So that completely answered the mystery. And it wasn't, when you looked at both sets of results together, it wasn't that the original sample wasn't her. It was just that most of that DNA profile was her husband. And just by chance, the Y chromosome, which would have indicated a male contribution, hadn't worked well, so hadn't been detected. And so you couldn't tell it was a male contribution. It just almost looked as if it was a woman, but it was not her. And actually, she was in there mixed with her husband's DNA. And that was what we found in the end. So it was quite a pleasing conclusion to that case, that they did find sperm.
That's fascinating, but also kind of great.
Yeah, well, I'm kind of used to gross. That's my sort of everyday is gross. So, sorry about that, having to mention sperm.
Oh, no, it's not that. I mean, like, it's gross that it's kind of like even after they've had sex, it's taken a while for the sperm to come out. That's the gross part. It's like,
yeah, well, I think the urine sample was only sort of a few hours afterwards. But if we're talking about sperm, just this might be an eye-opener if you're not aware of it. Semen can persist in the vagina for up to 10 days. 10 days. It isn't always detectable. I know, it isn't always detectable after 10 days, you know, that they're kind of outliers, but it has been found in cases after 10 days. Usually we're looking at maybe 3 days, up to 3 days, we've got a good chance of still finding sperm, you know, on those intimate swabs after that time. Sometimes maybe up to 5 days. Chances are decreasing after 3 days. But yeah, of course, sperm have to persist, don't they? Because if they all just fell out immediately, no one would ever have babies, would they, ever again? It'd be really difficult, you know. So I guess
that's very true.
You know, they're kind of doing what they're meant to do, really.
It's just the thought process of something inside you for 10 days when you're not expecting it. It's kind of like, And also that's, you know, it comes down to the point of a lot of things that we're watching on the television and movies, when they have like rape kits, for example, they're very much suggesting that if you wash yourself, that's it, there's no evidence at all, which is not the case either.
No, it's not the case. I mean, it was going to remove some, but it's not necessarily going to remove all of it. You know, you might still have traces left behind, even after washing, even after bathing.
And I do think that's a real problem. A lot of people are basing what they know, or they haven't even looked research, they're just basing it off these TV shows, as you said earlier.
Yeah, I mean, time is always going to be the biggest factor in sort of thinking about, well, what is likely to remain. You know, time is always got to be the thing you look at first, I think, before all of those other things. But there's a combination of things, isn't there, like anything, combination of factors that are going to affect, in every case, really, what evidence do we think might remain on this exhibit if that happened, as opposed to what might be there if it didn't happen or something else happened. But yeah, time, I think, is the one that you should always be thinking about first.
Oh, absolutely. And I think that obviously modern technology gives us, in a weird way, we think we've got more time because we've got quite things, for example, rapid DNA or VMD, when fingerprinting style, we think, oh, well, we can do that because if it doesn't matter if something fell in the water or, you know, this thing was buried, we still can get it. But it's a case by case basis, isn't it?
Yeah, absolutely. And I think another important point to sort of make here is that many forensic science cases will either result in there being no useful evidence, or evidence that is, we would describe as being inconclusive. In other words, it doesn't really help either way. And that doesn't mean there's anything wrong with the forensic science. That just means that that's what's there, or that's what isn't there. You know, and I think sometimes it's difficult maybe for police forces to get their head around it, because what we're not about as forensic scientists, it's not our job to find the evidence to match the suspicions of the police officer. You know, the police officer might think, I think that guy did it. Well, it's not my job to find evidence that he did it. It's my job to have a look and see what evidence is there and what might that say, you know. And yes, we do that within a framework. So the framework might be, it could be him or it could be somebody else, you know, but it's never, right, we'll find you some evidence that fits with what you think, because that would be incredibly dangerous and incredibly biased. You know, what if the police officer's hunch is wrong?
I think that, unfortunately, that happens a lot. I'll say 60s, 70s, when evidence wasn't collected as well as it is now, and everything was skewed so that people potentially have been arrested and put in jail. But that's again where you come in, isn't it? Because there's a lot of cold cases or people in prison. Unfortunately, not enough of them are getting out if they are innocent. But that's something that you also work on as well, isn't it?
Well, it's something that I feel very passionate about. I've worked on a number of I'll call them potential wrongful convictions, because actually it's not for me to decide, is it a wrongful conviction or not? All I can do in my role is to review the forensic science and then say whether I think either something's been missed or something has been misinterpreted. And I am often horrified and a bit frightened when I find a case where there is something that really has gone wrong, or something really has been badly misrepresented. And it isn't always the fault of the forensic scientist. I think they come in for a lot of stick, you know, oh, this forensic scientist has done this wrong. It's probably not that. It may be that the court, perhaps at an original trial, has misinterpreted what the forensic evidence says. So a particular case that springs to mind, and I won't give any names or details because this is one that I think is going to go to appeal quite soon. But again, it's another sexual offence case. A chap has been accused of rape, and the person he's accused of raping was a family member, so that their DNA profiles may potentially be similar because they're related. And he denies that this happened. And when you look at the DNA evidence, it doesn't really support the view that it did happen. Most of it is largely inconclusive in that it doesn't really help. Some of it, in my opinion, supports the view that it didn't happen because there is evidence missing, particularly from the inside of his underwear, that I would expect to be there if he had done it, if he had had sexual intercourse with the person accusing him. But what worried me most of all was that there was some very, very low level, and again, it comes back down to low level DNA evidence. There was some low level DNA evidence. It was found on the back of a pair of knickers that the complainant had been wearing. And it was interpreted at the original trial that this DNA, this trace of DNA, was from him, or that was how the judge interpreted it and directed the jury to kind of think of it, that this was his DNA. And that's completely wrong. The reporting scientists in the original trial didn't say that it was his DNA, but they reported it as a match to him. But it's a complicated mixture of DNA. But when you look at the bits of it that match him, there are 3 dodgy components out of a total of 20 components. And that's all that solely matches him and doesn't match anything else. And the rest of the DNA matches either the complainant herself or the owner of the vehicle that they were in, and the defendant admits that they were in this vehicle. And so there's a perfectly reasonable explanation. And in fact, even if those 3 sort of low-level dodgy components are his DNA, they may well have been transferred from the inside of the car as well, because what we later learned about this scenario was that the complainant was often known to wear kind of low-slung trousers, you know, where a bit of your knickers or your G-string stick up out over the back of the trousers. And that's exactly the position of these, where these DNA components have been recovered from. So in my view, it's quite feasible that the surface of her underwear could very easily have come into contact with the passenger seat of the car, and DNA could have been transferred that way. And it was just a staggering sort of misinterpretation by the court at the original trial of the original evidence. It was kind of misrepresented, and they put so much sort of emphasis on this one piece of evidence, and that was what had convicted him. And that really, really frightened me. It really worried me.
It's very similar to the Meredith Kircher trial with the touch DNA on the bra part. And it does come down to interpretation. And I do think that, especially with forensics, people see it as a black and white science. But if you get a lawyer who can say, well, if you've got DNA, that's it, end of case. And then they can persuade a jury, you know, matter what facts you give them, a lot of people can twist it. And you know,
I mean, there were huge issues with the Meredith Kircher / Amanda Knox case, because the crime scene had been trampled through by kind of the will and his wife, you know. And this one, though, I mean, there are a number of bits of DNA that I think in that case there was some on a knife handle,
toilet, I think.
It'd been recovered from her Amanda Knox's boyfriend's place, but it had perhaps been taken from the place where she was living. So there were questions about that. There was also this bra strap that was probably, by the time it was recovered, hugely contaminated because there was a huge delay. But I'm going to pull you up about one thing that you said. You described it as touch DNA. And I am always telling people not to do that. So consider it a telling off, but in a nice way. Because the term touch DNA, and it is used very widely by police officers, they'll be saying all the time, can you do touch DNA on this exhibit? Well, we know what you mean, but please don't call it that, because touch DNA implies that DNA was deposited by touch, and it might not have been, you know. And there's no way that you can distinguish just by looking at the DNA profile between DNA that was deposited by touch and DNA that was deposited perhaps by some other means, you know, indirectly via another surface. So really, there's no such thing as touch DNA, it's just DNA, you know, but I know exactly what you mean, you know.
We love a good catchphrase though, don't we? It's
Yeah.
especially
Well,
in the
problem. It's really catchy, and it worries me now that some prosecution instructed experts are starting to write sort of their own technical issues in their statements and calling them touch DNA or contact DNA as if somehow that is something that you can identify specifically, and actually you can't. So I'm on a bit of a crusade to correct that as well, because it worries me, you know.
Definitely needs to go into the forces, because I think it's one of those things, like, when, even though, you know, you get trained up and you know what you're meant to say and everything and how you're meant to do things, as soon as somebody repeats something over and over and over again, you just don't. It's the same with, you know, English language. We say words that don't make any sense and then they become verbatim.
Yeah, and I'm sure touch DNA, maybe years down the line, it's starting to happen, will be adopted. But I wonder if there's you know, there's no slick kind of snappy phrase that you could replace touch DNA with, you know, because I will call it low level DNA, or, you know, but it's
definitely not as catchy.
It's not as slick, is it? So yeah. As long as I think the people talking about it understand what it means, and the problem is that people hear it and they've not heard it before, and then they think it's something that it's not. So that's the worry. I think we have to strive to be as unambiguous as possible in forensic science, because it's so easy to misinterpret something that somebody else has said, or they've meant it in a different way, and that is how you end up with you know, misinterpretation of evidence and people on a jury thinking something that isn't quite correct, you know. So we just got to be careful, I think.
Oh yeah, no, I've learnt my lesson. I will try and say low level DNA from now on. I'll probably end up saying touch DNA by mistake, but I will try and remember, I promise.
Yeah. Well, I mean, you know, if you say it and then you describe why it's perhaps ambiguous, that's what I've been teaching my students. I don't mind if you use it, as long as you explain what it is and what it isn't, you know, then I'm happy.
Good. Well, you know, I know we've been on for a little while, so I just want to ask about more DNA questions before you go off, if that's okay.
Fire away.
Because obviously we've talked about urine, and I don't think we made it clear that this is new, really, because, you know, it's an ideal world. It'd be great to be able to profile urine, especially for drug testing, but this is a brand new, really, in the world of sports. Does that mean that other DNA that isn't as obvious, so mitochondrial DNA, other forms of DNA, potentially on hair and anything, we're coming to a point where we can find more profiles and more evidence from it than we, say, used to 5-10 years ago?
Well, yeah, I think generally that's true. You know, DNA is, and I mean, it's not, the whole urine thing is probably not that new, but it's kind of new to me, but I'm a bit of an old giffer now. So the kind of the sensitive level of DNA profiling that we have in the UK has been around since 2014. So not that new, you know, it's been around for a while now, but it still feels new to me. There are next generation sequencing solutions that I'm sure will be coming online in the next few years that can do other all singing, all dancing things, and allegedly can help to resolve mixtures of DNA, that kind of thing. So that will be interesting to look at in the future. But, you know, generally, all kinds of samples now can be tested, you know, just using what is now standard DNA profiling, and they will often give results that we wouldn't have expected pre-2014. The difficulty, again, it's going back to those limitations of low-level DNA profiles. We always like to, as scientists, have a good idea of what we expect from a particular test. So that's what we will do in what we call our case assessment. We'll do an upfront case assessment where we decide what is the forensic science strategy in this case, what exhibits will we examine, what tests will we do, etc., etc. And during that, we will consider what the outcomes will be. And so it's all about using that conditioning information that I mentioned earlier to determine what am I expecting when I test this or I examine this, if that happened versus if the alternative version of events happened. So that's kind of what we do. But the problem with the sensitivity of DNA profiling is now we often don't know what we'll expect because it's a bit hit and miss, this low level stuff, you know, DNA from maybe something that's been handled, maybe from a bit of sweat, you know, maybe from urine. I mean, we're talking liquid urine samples with that particular case. I still maintain that probably you're not going to get much from a dried urine stain on a garment, for example, because there's less material in that. But you would probably detect some DNA. You've got to ask a lot of other questions then. Well, what's the garment? Who's worn it? When was it last washed? How long has it been that people have had contact with it? You know, you could get all kinds of DNA on it. But coming back to that sort of case assessment and that strategy, with samples that are in the realm of either things that have been handled or things that might have low levels of DNA on them, you just don't know what you're going to get. You have to do the test and then look at what you've got. And so it's a bit more uncertainty to deal with. And I think generally you just have to be very cautious in interpreting those profiles. You don't want to be interpreting them based on what you want to see, you know, or hoping that you see somebody's profile reflected in that, because then you're sort of leaning in a particularly biased way towards one particular outcome. So sometimes it's hard to be objective. But generally, going back to your original question, because I've waffled on a bit, I think it's true that we can certainly, generally speaking, try tests and expect to get something where previously, pre-2014, we probably would have expected not to get anything from those kinds of samples.
And I'll ask my final question, I promise, and then you can be free to go and enjoy your Friday. What do you think about this genealogy testing that everyone seems to be getting at home, kit? And then secondly, on that part question, there's some people who are using them to find rapists and potential murderers. What do you think about that?
There are a number of points to be made. The good things about them, yes, kind of, it's useful if you can look for a DNA profile of a relative of a person of interest, if you like. If you can find a profile that's similar but not identical, then maybe that's a relative. And that certainly happened before we had all these companies who do ancestry DNA testing. You know, that's something that the FSS could do. There's a case of a young boy who was murdered, Imran Vora, he was called. A colleague of mine worked on it. Another Sue Cherry. Hello, Sue Cherry, if you're watching. Very, very experienced, very senior forensic scientist. And in the Imran Vora case, they were looking for the murderer of this small boy and ended up recovering some DNA from an exhibit in the case. I don't know what the exhibit was. I think it was an item of his clothing. Searching that against the National DNA database and it matching almost a person on there who was then thought to be a relative of the actual murderer. And so that's how the actual murderer was found in the end, by doing this kind of what we would call familial searching, where you look for near matches but not exact matches. And it was quite interesting. In the end, they managed to find out that the chap who was thought to have been the perpetrator had died before he was identified, but they were able to obtain a sample of his DNA from a medical tissue sample from a biopsy that had been taken from him and had been stored by the FSS in a wax block. And that was very, very interesting, just from a kind of a geeky point of view. So familial searching and finding people via near matches can be quite useful. But the problem I have with these ancestry companies who do DNA testing, when you're looking at the information that says, well, where are you from? You know, are you 50%, I don't know, Egyptian and 20% Irish, and whatever it is, you know, that they say. I'm just a bit skeptical about those sort of interpretations, because what people are finding is, depending on which company they send their sample to, depending on which sort of algorithms and whatnot those companies use, will depend on the answer that you get. So people are getting vastly different ideas of what their genetic ancestry is based on the different work that these different organisations are doing. And the problem with it I have is this: you can only compare to a particular population as it is now. So that doesn't really take account of the migration of people over many hundreds or thousands of years in terms of what populations were like then. So when you get a result that tells you you're, I don't know, 30% from the Middle East, that can only be based on the genetic sort of profile, if you like, the genetic population of the Middle East or whatever region as it is now, which probably is nothing like it was way, way back in your ancestry. So in my view, the results of these tests that tell you, you know, what your heritage is and where are you from are a little bit bogus, I think. They're just a bit inaccurate, you know, because you're not really looking at the population as it was those generations way, way back, because you can't do that. And so the different companies will use different sets of data to come up with these answers. It's no surprise that they're all giving radically different answers, you know, and ultimately, if you go back enough generations, we're all kind of related anyway. You know, we've all come from a number of common ancestors. So the further back you go, the less meaningful I think it is anyway.
So obviously to find it, you know, we probably all, you rightly say, part of the same ancestry group way back in the day, but if you were going to find, say, a long lost cousin, then potentially it could be your benefit.
Oh yes, potentially, for identifying specific individuals, either if that's individuals who might be relatives of me that I want to find, then certainly yes, it's useful to do that. Or in finding people who might be criminals based on matching information to their relatives, that's a potentially useful path of these. There are certainly then questions to be answered about, you know, human rights and civil rights and all of those other things that are sort of not really in my remit as a scientist, but things that also need to be, you know, equally thought about and are of equal importance. And that's a whole can of worms that we perhaps shouldn't open at this hour, right?
I think sometimes, yeah, it can get into talk of eugenics, can't it? So, and human rights is a very important thing. I know that in America, they have used these tests to find killers and rapists, like they're, you know, your average Joe off the street, not police officers. But it is a bit weird. I mean, who knows, going forward, you know, people are less likely to care so much about their own human rights because they're putting stuff on their phones. They're, you know, doing things that we wouldn't have done 10, 15 years ago, but you know, that's their own judgment.
Well, I think it's one, isn't it, that people often don't think about unless it impacts them, you know. So if you upload your genetic information to an ancestry website, that's fine. But what if then somebody accuses you of a crime based on that information being on there, you know, and perhaps the legislation isn't in place yet that will help us deal with that. I don't know. It's not my expert area, but it's certainly really important to think about, isn't it?
Yeah, especially as, you know, people are going to be doing that kind of thing anyway. I think it's a weird case, isn't it? Legislation should come first and then these technology movements go forward, but that's not how the world works.
Well, it's not the real world, is it? Because the legislation is always sort of playing catch up, because, you know, the people who make the laws haven't thought this is what we might do in 10, 20, 30 years from now. And so the technology suddenly is accelerating and moving really quickly. The laws try to keep up with that, I think.
I agree with you. Well, Sue, I'm going to let us go because we've been on it for an hour and I've had a really great chat. And I honestly could carry on talking, but it's Friday and I'm sure there's wine to be had in a garden somewhere.
Absolutely, yes. Perhaps not in the garden tonight, but there's certainly wine to be had later on.
Always. Thank you so much for joining me today. I really appreciate it.
It's been a pleasure. I've really enjoyed it.
Oh, well, we'll get you back on, that's for sure.
Absolutely. Happy to. Take care.
Thank you.